Cool. So now what we'll do is we'll read all the images using a for loop and then compute the average. So a for loop is for lazy people who don't want to write things again and again. So the I will go from 1 to the number of images that I have, and I know that all my images or all the names of my images is in the variable called files. So what I can do is I can just type length of files. Length of files will give me the number of images that are there in the file. So you can see 10 over here. So I goes from 1 to 10, and basically what I want to do is I want to read the image. Maybe I can just rename this to current subject for some, I mean it's good to name your variables for better understanding. So this is the current subject, and then what I'll do is I want to, so for creating an average, what I'll do is I read the subject, I have the image, and then I keep it into a dummy variable called, let's say, temp. Okay, so let's say temp is the current subject. Oh, okay. So initially, if I equals 1, so for the first image I'm going to create this temp variable. Else what I'll do is I'll just say temp is equal to temp plus the current image. So what this is doing is it is basically adding all the images and putting it in the folder in a variable called temp, and that's it. So when I run this particular for loop, I'll get a variable that is temp, which is the addition of all the images in the subject in the folder. So now to get the average, let's say average image, it's just temp divided by the length of files. So that is the sum divided by total number of images. But when I execute this, it works. Okay, so because length of files is just a single scalar, is just a number 10, this works. But usually if this was an array or something like that, it won't work. It would take this as matrix multiplication, and so then dot would be required. But anyways, it works now, so I'll not go into that. Okay, so yeah, so that's your average image. Let's just view how the average image looks like. So let's say I just created the function my ortho slice viewer. I put in average image. Oh, it's already there. And there's a problem. You see the problem? Exactly. maybe when you average out all 10 people's brain, you just get nothing, which is kind of true. Maybe, I don't know. I mean, a lot of cooks spoil the broth, so yeah. But okay, that's not the reason over here. So something is going wrong. I averaged out all the subjects image. So I read the image, put it in current subject, I put it into a dummy variable, keep on adding the images, and that's stored into this temp, and then I divide it with the number of images that I have. So it should give me the average. Why isn't this working? Exactly, the data type. Yeah. So as I told you, right? So the data type over here is int16. So what a int16 is, let me do it here. So let's say I create a variable a and I want it to be int16. So let's say 1 2 3 6.7 5.5.8 5.79 or even -3. So when I execute this particular function, when I create this variable a, notice all the points are gone. So I had 6.7 here, but then that got converted to 7. I had 5.7 over here, that is 6 here. Okay, so so this particular data type, as it says, it's int means integer. So an integer cannot have floating points. So if you so if a is int16, if you anyhow try to change this and want you try to make it a floating point, it won't accept it. It will just round it off to the nearest integer that is there. Okay, so that is the problem. So when I was accumulating all the subjects, if I can just open temp, you see there are a lot of zeros, and then there are these big numbers over here, 32767. I don't know what is this. So it turns out that int16, that means 16-bit. So int16 integer, 16-bit. So all the elements in an int16 variable is stored using 16 bits. Now what that means is the maximum possible number that you can get is so the range is 2 raised to 16. So this is the range that you can get. You can have 65536 different numbers stored in this data type. That's it. So here's my a. If I try to put a very big number, it will just round it off to the maximum possible number that is allowed in an int16, which is 32767. Notice this is different from what I typed over here. So this was 65536, but somehow it gives me 32767. Any thoughts on why this is the case? Yeah. No. So I mean, actually, yeah, that's right. Yeah, that's right. Exactly. So this consists of negative and positive numbers. You're right. So there's one bit for negative numbers. Exactly. So the first negative numbers. Okay. Let me just do this. So if I have a big negative number, oh, that's not a big negative number. This is a big negative number. So there you go. So the minimum possible number that you can have in an int16 is 32768. This is not visible, but just believe me for that. So this is minus 32768, which is actually 6355. Oh, 65536 divided by 2. So it starts from there, and then there's a 0 in the middle, and you have all the positive numbers. So that's how you get the range of int16 data type. So now what was happening is, when I'm keeping on adding the images to this dummy temp data type, the dummy temp variable, at certain point all of them are exceeding this particular number 32768, because of which anything about that is just 32768, which is a white in MATLAB. So to resolve this problem, what we can do is just change the data type. So the problem is solved if you just convert whatever image you read to double. Now if I execute this thing, I hope it works. Let me have a new figure. What was the name? Average image. Yep, it works. So the average of all brains is not a null brain. It's something like this. That's the average brains. So the data that I'm using is all aligned. All the brain images are aligned together. So so that's the reason why I'm getting this good image. If let's say the images were not aligned, if one subject's brain was here, the other subject's brain was here in terms of images, then I would get a very blurry image over here. But because everything is aligned, you get a good average image here. So these images are aligned into what is called as an MNI space, which is a standard space for brains. So what happens is all the individual subject images are transformed such that they are squished or stretched a little bit so that I can match all the ventricles of all the subjects together, and the shape as well. So some brains might be small, some brains might be big. So the bigger brains are, squished a little bit, the smaller brains are stretched a little bit, and then you try to map it to a template which is called the MNI template. The MNI comes from Montreal Neurological Institute. They were who created this standard space. And yeah, so because just for demonstration purpose, I had all the images in the MNI space. That's the reason why you get a clear image like that. Yeah. Oh, you mean to say why did double work and why didn't int? Yeah. Okay, sure. So if you look at the int16 data type, where is that? A. Yeah, A. So if you look at this data type, so what am I doing? I'm adding all the images together. Okay, so if the value goes above 32767, let's say I'm trying to type 555555, a big number. If it goes above that particular value, it will just round it off to 32767. Okay, so what is happening is when I look at the temp variable, yeah, I'll have to rerun this. So now temp is a int16 variable. So now if you see at the middle, they are just saturated and they only have these numbers 327 because those were very big numbers, so they all got rounded off to 32767, and that's what corresponds to white in that grayscale. And that's why the information is gone and I can just see the same number everywhere which corresponds to white, and so everything became white. So you change the data type because double is a data type which so double uses 64 bits, so double also has a range, but so this just use 16 bits, so this is good for storage. I mean, if you know that your range of that particular image is within this minus 30,000 to plus 30,000 something, then you can store it as int16 because that's better, that's more, that'll take less memory. but if you know that the range is bigger, then you use double or something like that, which uses more memory. So double is good in terms of computation, and double can also have floating points, but double is not good in terms of storage. I mean, int16 uses lesser space as compared to double. So we saw data types can create problems. So for instance, int16 won't accept floating points, and it is within this particular range. Oh, there's a mistake here. It should be divided by 2. So the -1 over here, the -1 over here is because there's a 0 in the middle. So you also have to account for that 0. So that's why you go from minus this by 2 to this by 2. Yeah, minus.